So no talking like pirates tonight. We're going to...
Good evening, John.
Hard. Okay. Everyone has to answer one question like a pirate. Kind of thing. Tonight's panel is kind of a joint presentation from CppCon and also the local Northwest C++ users group. And so we are here with people who have specific offices in the Standards Committee, and I'm going to allow them to state their name, but also tell us what their particular office is. And I'd like you to also tell us how long you've been on the committee. Maybe you guys don't have that many fingers and toes, I don't know, but some of you have been on for a while. So we'll start with Bjarne. You want to tell us your role and how long you've been doing that?
Hello. Yeah. Okay, so I'm not quite sure what my role is. Maybe troublemaker and chief. Well, I've been around for longer than the committee. I was at the non-committee meeting in Washington, D.C. in, what was it? 89? Yeah, it's a long time ago. There was a meeting that arranged for the committee to be created. So, that's it.
I'm Hans Bohm. I chair the concurrency study group. I've been around, well, longer than the concurrency study group. I think my first meeting was in about 2004 or so. The concurrency study group sort of deals with concurrency papers that come up. It's also slightly odd among the C++ study groups, and then we also deal with issues in the area of concurrency in general.
I'm Richard Smith. I'm the project editor for C++. I've been attending committee meetings since the start of 2012, just after the C++ 11 standard shipped.
Richard, what is a project editor?
Okay, so in the process of putting together a standard, many people work together to produce papers with functional changes which eventually turn into specific wordings we apply to the standard. And my job as project editor is to collate those changes into a document which we can then present to ISO. In some ways, it's like I'm a glorified patch tool that the committee points papers at.
Hi, I'm Casey Carter. I work for Microsoft. I'm the project editor for the Ranges TS, I suppose. I've been going to committee meetings since basically March, Jacksonville, when I was first a member of the committee, so I'm pretty much the young officer here, I suppose.
I'm Marshall Clow. I've been attending committee meetings since, well, started the same time as Richard did and Chandler did, early 2012. And as a newbie a couple of years ago, I didn't duck fast enough, and for my sins, I am the chair of the library working group.
Okay, so my name is Michael Wong. I think I've been attending committee meetings since the early 2000, maybe 2002 or 2003, pretty much right after I got married. So that was the punishment. I'm now the chair of SG14 for low latency, the games developers, as well as SG5 transactional memory. I'm the editor of the concurrency TS, as well as the transactional memory.
So you joined the committee right after you got married?
That's exactly, that was my idea. That was my
Listen, right now I'm discovering in real time for the first time why now your picture that you've always used for us has been in a tuxedo. It's you in a tuxedo, that's why. Oh, one last thing, patch tool over there, that's a brilliant patch tool. It's project editing is not just mindlessly putting together patches.
It's not just cut and paste.
I've been in the committee for almost 20 years now, actively, and somebody reminded me this year that if you count the committee from starting in 1989, when they were first starting to talk about organizing it, I've now been the convener for half the lifetime of the committee, which is just wrong.
My name is Chandler Ruth. I'm the chair of the Reflection Study Group, and I've been on the committee since 2012, early 2012.
All right, and I'm happy to be up here because I think I treat all these people with a certain amount of respect, and this is my opportunity to cut them off and say, we have a lot of questions to get through, you're being too long, or being repetitious, it's time to move on. So I'm going to be rude to you guys tonight. I'm going to actually, to kind of kick things off, I'm going to flip the tables on you, because although you guys are all standards guys, you're also real users, right? I mean, I think you actually write code sometimes. So I want to, and I'm going to force everybody to come up with an example because I hadn't prepped you for this, but I would like somebody to come up with an example, many as you can, of something that in your work in the last X months or year, you found some new feature of C++ really helpful in a way that nobody really anticipated, or at least you hadn't anticipated. You were working on a project, and suddenly you went, oh, I can do that, can't I? So anybody have a story you want to share? Shannon.
So in my day job, I work on the LLVM compiler, and I was working on, I don't know if you guys know anything about compilers, but it's all graph algorithms. Like, it's all graph algorithms all the way down. And I was working on a particular graph algorithm, which is trying to simultaneously update the set of strongly connected components in a directed graph, and also try and update a topological sequence of nodes, of SECs in that directed graph, and discovered that in fact the algorithm I needed to do this was first a depth-first search, followed by std partition. And so this is yet another, like after Sean's famous talks about std partition being used to implement, you know, so many different features, right? Like I had my own moment of like oh, I just wrote a really bad version of std partition. And replaced with the call to std partition. It was really nice.
Very good, very good. Anybody else want to own up to doing real work?
Well, I was just working on a toy project of my own lately, and the thing that surprised me the most about C++ 11 is that it added more support for allocators. I had predicted that if anything happened with allocators, we would start ripping them out and saying, oh no, we did too much of that, but no, we did more. In the last month, I have become very glad we did that, because I did not have a need to write an allocator until the last month, and suddenly I learned a lot about how to write an allocator. And did you know they can have fancy pointers, user-defined pointer types, not just raw pointers? Turns out this is really useful. And the STL collections and allocators are way more extensible, as they already are, than most people think. So that generality, that something designed in the 90s plus the additions and allocators in C++ 11 could let you do so much that hadn't even been anticipated then, that it's this great framework for extension, was a real revelation. And I actually kind of enjoyed writing an allocator. But if you do it, use Howard Hinnett's allocator boilerplate. Don't try to figure it out yourself.
So I can definitely follow up with a similar story about allocators. I've been working on a lock-free programming interface with Mag and Michael on hazard pointers, and one of the things we kept struggling with was how to do it as how to set up the allocator. And we actually essentially reinvented it until we looked into what PMR does, polymorphic memory resources, and realized that we can essentially take most of the template from that and essentially do exactly the same thing. We wrote a very poor one, but found a much better one in the standard. So there you go, always check the standard.
I have been amazed by how much lambdas have changed the way I write code. I was totally expecting that they would make it simple and beautiful in places where I used to write functor or classes. What I wasn't expecting is all of the other places where I just have a little bit of duplicated code that uses some local variables, and it wasn't worth factoring it out before, because the end result would have been worse. And now it is, and you get something which is elegant and simpler and easy to understand.
I think the first thing I'll mention is, that wasn't really a surprise, except that I was trying to create some plug-and-play stuff, and the fact that we had template aliases, template default arguments, concepts, which I had to fake disgustingly, and lambdas allowed me to hit so close to the zero overhead that it's quite nice. The other thing I found that I accidentally reinvented some of the scope guards, and they are horribly misnamed because everything's to do with scope guards. So I now have finally on error and on exit. But apart from that, I just innocently reinvented the wheel.
Okay, so we have a couple of microphones here. Go ahead. Anyone has a question? I'm going to start off with the obvious question, which is, and I do want everybody to answer this. The obvious question. Yes, the obvious question. What is your favorite feature of C++ 17?
Structured binding.
All right. Structured binding.
With thanks to the people who helped me write the proposal, especially Bjarne and Gabby, structured bindings.
Come on, guys. Parallel STL.
Well, I have to say that it's the generic searcher interface because I wrote that. But really, it's string view.
Say standard variant. I think it's a really, really widely useful tool that is incredibly powerful now in the standard library. You don't have to mess around with unions anymore.
Stands our vocabulary.
I would probably say context for F.
I'll also have to say the parallel STL, though I'm still waiting for the opportunity to actually use it.
Let's see, not to be repetitive, let me point to template argument deduction for constructors.
All right, well, thank you, guys. I think we have some people lined up here. Can you say your name?
Sure. Sure. My name is John Bandella, and I have a question about C++ 17. In April of 2015, I think Bjarne wrote a paper, Thoughts on C++ 17, where he listed his top 10 features: concepts, modules, ranges, uniform call syntax, coroutines, networking, contracts, as well as vocabulary types. And he put in there that he thought that these were definitely doable by C++ 17. Obviously, not all of these made it into C++ 17. Just what happened between now and then, and what are our expectations like going forward?
I'm sorry.
I'm still an idealist.
I'm sorry you missed your plane this morning, John. Because Bjarne talked a lot about that this morning.
Thanks.
So since I get to organize the committee and arrange meetings and stuff like that, so first of all, that is a very accurate list. Nearly everything on that list has in fact been shipped by this committee or is about to be shipped by this committee, if not in C++ 17, most of them, in TS form. And what's even better, have implementations. Now, I know Bjarne would really love it to be in C++ 17 in the standard, and that didn't happen. But I lived through the late 90s. Many of you lived through the late 90s. If you didn't, and if you were a C++ programmer, you do not miss having a paper standard C++ 98 that nobody implemented fully for 5 years. Paper only goes so far. Yes, there's the argument that once it's in the standard, organizations can rely on it, but only if there's implementation. So if I have to pick one, I pick the implementation. And we're not yet in the place where you can try concepts and modules and coroutines in the same compiler. But you can try each of them in a production shipping compiler, and that's really cool. Having said that, I've been talking to several committee members just today who already came up to me saying, you know, as soon as we ship C++ 17, we ought to immediately airlift XYZ into the C++ working draft for 20 to be able to massage it and smooth it, including probably the most conservative member of the committee who I won't name, who wants to airlift it in as soon as we ship 17. So I think some of these things are going to be in the standard sooner, but try them out. Give us feedback on how they're usable.
It's Richard. And question, a GUI library, do we need it? And if so, when do we get it?
Are you asking about the 2D graphics, IO GUI?
I'm not going to take every question, but there is a proposal for that. There is a proposal for that I've been encouraging. It's for 2D graphics. You'll probably never get one for frameworks and widgets because that's just not as portable, but there should be something for basic drawing, and so take a look at the committee pages. There's an updated proposal coming in a couple of weeks for the next mailing.
I would like to give the answer I've been given to that question for the last 20 years. It would be really nice to have a standard GUI. And we, at the time, 20 years ago, had 5 organizations, members of the committee, that had their own GUIs and was not going to compromise on anybody else's. In other words, starting GUI work was the easiest way of creating a civil war in the committee and making friends not friends anymore. We have revisited this issue many, many times, and it still looks roughly like that. And on top of that, creating a modern GUI framework with a group of people without any real organizational structure and no money is beyond us. We would need some kind of happy miracle of somebody bringing in something that really is good enough, and I think some of the IO study group is hoping to do something basic like that. But we were exactly in this situation about container and foundational frameworks when Alex Stefanov came with the STL. So sometimes miracles do happen.
Hi, my name is Frank, and just sort of a question for the committee as a whole. Do you find that the big barrier to getting things into the standard is either a resource problem or more of a consensus problem? And depending upon which do you find more common, do you have any ideas on how you guys might mitigate those risks so that you're more willing to get things in, you know, a way to acquire either more resources or convince people to try things out quicker versus be conservative? And
I don't know that it's either of those particularly. I think that the biggest challenge of getting new features into the language is that designing new language features is really hard, and it's really, really hard on a language that doesn't have quite so many users and quite so many hundreds and hundreds and hundreds and hundreds and hundreds and hundreds of millions of lines of code already written, right? The system is incredibly complex, and it's moving very fast already. I think that the thing that holds the committee back the most is just, you know, the nature of the beast, right? The nature of actually changing something this complicated with this many users, with this many very invested kind of, you know, stakeholders, right? And we somehow have to not break them while adding some significant value, or at least not break them too badly. And figuring out the best set of trade-offs there, that's the nightmare. It is both a resourcing and a consensus problem, right? But and the thing that I think has helped the most in the committee's work to expedite that is building focused study groups and putting out focused technical specifications that we can kind of implement and get feedback on and iterate on. Because that way we actually have a chance to figure out the integration problems before it becomes an international standard. And that I think is the biggest thing that lowers the bar, is to understand it that well.
I think my keynote was part of the answer to that. We don't actually agree on everything, and it is really very, very hard, and it takes time. We have to build up a consensus, we have to build up trust, and then there are people who have fundamentally different views about what risks are and what users might benefit from. It stretches all the way from how do you not break code to fairly deep philosophy.
Sort of speaking from experience on the concurrency group, I think it's sort of all of the above. I mean, there are cases in which it's really difficult to just come up with people to write proposals and then iterate them sufficiently many times, who have the persistence to iterate sufficiently many times until it finally makes it through committee. And there are also cases where we just have had trouble getting consensus because there are several competing proposals and they just can't agree.
I want to put some of this in context. We actually have far more resource now than ever. There are more people attending. Having been here for quite a number of years, consensus is actually much better. We're able to get to consensus, work much more collaboratively. But I just want to see, I see it from many different committees. I'm on a number of different committees. Some committees actually that are much smaller are able to, yes, they can add more things. I'm not going to name who they are, but you know what? Some of the things that, because there are fewer people, I actually think that they have less opinions being injected, and therefore I think they're actually making some more critical mistakes. What we're doing, I think, is the right thing, taking the right measured amount of pace. So, and yes, what Chandler said, it's the nature of the beast. The language is baked, making sure it crosses all the things, and we still don't cover it all by any stretch of the imagination.
Let me give an example. There are people who think that you shouldn't put anything into the working document till it is absolutely fully polished. And that can give years and years of work on a document. And people take very little notice because it's still in a committee. And then it comes up and people haven't seen it and you have nervousness and it has trouble, and then there's more delay. The other strategy is to say, well, we screw up. Let's put it in the working paper, see how it integrates with others, make the decision that this is the direction in which we go, instead of having endless new versions come up and new designs, competing designs come up in the last stages after years of work in the committee. It's very difficult. We don't have a solid enough process for dealing with this. That's at least my opinion.
Okay, just to program up, people on that side of the auditorium, you can ask questions too.
Hey, so my name's Chris. I'm wondering, based on what Bjarne was saying this morning about with the CPP core guidelines being explosive, with C++ 17 being explosive, just generally C++ becoming explosive from C++ 98 through to 11 and so on, what your expectations on educators is, so how we should go about teaching it. Should we start with 14 and then move into 17 throughout the semester, or should we move on to 17 now? Should we just teach, as Bjarne was saying, C++? What's your take on that? Sorry, that's a question for anyone, not Bjarne himself.
I will give a start. I won't exactly answer your question, but I'll give you a start. And the start is that I still run into lots of people with teaching C++ 98. And let's not do that. 2011 was 5 years ago. Okay, that should be at the very minimum in C++ 14 at least, actually. But if people are still teaching bind first and bind second and things like that, please just stop.
Oh, you're lucky. I mean, there are lots of people who are teaching basically C with classes and delay the introduction of vector and don't touch the algorithms till the advanced course where everybody's gone to sleep. So putting back my hat as an educator, both of students in universities and industrially, I think the language, as seen from a programmer's point of view, is still C++ 11 that you should teach. You can use 14 features and 17 features as are available. It would not change your major curriculum. And but get everybody on board with 11 and 14. Please. It's much easier. There's fewer bugs.
I have a slightly different suggestion. I think you should teach what you can compile. You should teach what your tools support. My biggest fear is that people are learning C++ without some of the advances of the C++ ecosystem, and they're just focusing on the language itself. And the language has advanced tremendously, like please, not C with classes, right? But also, you know, not just an old compiler, don't leave all the tools, all the error messages on the floor, don't make your students suffer through that, right? Get a very modern compiler, I don't care which compiler, like they're all fine, but a really new one, right, where people are trying to make the experience for programmers better so that they actually enjoy more of the programming rather than struggling with it.
So I'm gonna insert a commercial here. I think we have a panel tomorrow at lunchtime on teaching C++ at college level. So anyone's interested in that, I urge you to take a look at the program for that. Okay, so what's your name?
Hi, I'm Matt. Just more of an exploratory question. I've heard a lot of rumblings from sort of the more data-driven design type people about how C++ is sort of becoming a bit bloated, and there's a lot of features coming in that aren't really, they're sort of built on top of what's there, but they're not implemented in an incredibly elegant way. And almost everybody I talk to has some aspect of C++ which they think could be implemented more elegantly given the modern context and what we've learned and this sort of thing. I already know some of the answers to this, but just as an exploration, I think it would be useful to just explore what the possibilities in the future there are of having either a standard library 2.0 or a C++, as it were, basically saying, okay, at this point we have ABI breakage and we acknowledge that, and here's the old set. Why that may or may not be a good idea / bad idea, or why it wouldn't work, etc.
One of the things that we're hoping to get out of some of the TSs that are in flight, in particular the concept of ranges, is enough knowledge and enough experience to basically write an STL version 2 or a standard library version 2. This will not be an ABI break, but I can't imagine anybody getting rid of their existing standard library because, as Chandler said, hundreds and hundreds of millions of lines of existing code. But this would be something new that people could transition to at their pace, and yeah, taking the lessons that we have learned over the last 20 years, whether they be minor things like, oh yeah, we got the return type of this thing wrong, or major things. It's just, we're looking at that. We're all kind of eager to see to work on that, but it's not here yet.
Yeah. STL2 will be more elegant, more powerful than the original STL. It'll be able to do what the old STL was doing and better, and it'll do more things. I'm looking forward to sorting a vector as opposed to sorting a range. Of course you'll still be able to sort a range and you'll get the same answer. We're not going to break all of that code, but we will move forward, and there were mistakes made over the last 20 years. STL came out in '94. We have learned one or two things, even Alex had learned one or two things, so something will happen. Casey is sitting right there. Would you like to say something?
Eric is out there in the audience somewhere. I don't know. They covered most of everything of what I would say. We are planning to make an STL2, but the idea is that it's going to be an expansion on the original standard library, I should say, more than a replacement, so that old code, to the extent possible, will work with the new library, and new code will be able to use the old library as well at the same time, side by side.
I just wanted to comment on one other aspect of all of that. I don't know anything about STL2. You trust what they say there. But I heard this comment about features in the language not being implemented really well, or getting bloated or carrying overhead in some way. I don't see any evidence of that. I would love to know examples of where people are struggling with that. As far as I can tell, the features that have come in since C++ 11 have received more thorough design review, have been more carefully and effectively implemented, that are tested and are some of the best incremental improvements to the language I have ever seen, especially on the implementation level. C++ is a faster programming language now than it has ever been, and so I don't entirely believe these rumors in the rumor mill. Everything I see looks really good.
Hang on just a second. Gasper, would you step to the microphone? Would you like to comment on the speed differences between what we see with older compilers and new compilers? Do you have an example for us of that?
Sure. So I recently completed a 3-year project to port our code base of...
And what's your code base?
The Amazon search engine. From using GCC 4.1 to 4.9.3. By the way, we haven't turned on C++ 14 yet because that breaks badly. But that was on the low end of 15% speed up, and on the high end 18 plus.
So you got 15 to 18% speed up just by changing the compiler from a pretty old compiler to a modern compiler.
Yeah,
that's not rewriting your code.
That saved a non-negligible number of millions of dollars.
Back up a second. GCC 4.9 is years old.
Well, yeah.
He's halfway to the current day.
He said GCC 4. You know how long I had to teach people 295.3?
Yeah.
and I would just like to comment that there was a very small feature added to C++ 17 in Ulu, I think it was, for those people interested in future standard libraries. We reserved a whole set of namespaces for future standardization. Any namespace who starts with STD and continues after that with just numerals is now reserved for future standardization. 2, 3, 4, 47, 893.
Unbounded set.
It's an unbounded set. STD 2487. That's going to be my favorite.
All right, so we have a question over here.
There seems a watershed between the old school of C++ and the modern C++, and often come across modern C++ in the literature and the talks. I'm just wondering what characterizes this modern C++. Can we write modern C++ using the C++ 03? Just wondering.
There's a lot of aspects to that. The modern compilers are better. I could report, if I could, some results that is similar to those simply by cleaning up the code so that the peculiarities of non-standard code and old code bases disappear, and then run them through a new compiler. The reason this works is that new compilers take advantage of modern hardware better than old compilers. Code also gets smaller and cleaner. Less work for the compilers, less work for the optimizers, so it helps. So we want to move people along, and there's very definite benefits on that. The question is how. And I don't know if you was here last year, that was when I launched the guidelines project, which is specifically aimed at moving people forward. I don't know what modern C++ is. It changes every year, and it should keep changing as long as we can make significant improvements. But people need help. People need help to be told so that they don't have to discover by themselves which techniques work, which techniques clean up your code, which techniques gives good performance, and which of the old ways have new and improved ways. And so the guidelines project is aimed at that, and we are looking for tools so that people don't have to actually go and read their code to figure out where they are doing old style stuff. Instead, you can have tools to do it, and we would like some of that to work their way into course plans, curriculums, and textbooks.
Thank you.
I think the word modern by itself changes with time. There was a great book that Andre wrote in 1999, I think it was, or 98, Modern C++ Design, which was, and it was a great book. Of course, now it's almost 20 years old. and so it's no longer modern. But today, if you were to ask, I would say it's very similar to Bjarne earlier at a previous question. The baseline is C++11, and you can look at code and know whether it's doing the things a modern way or not by whether it's writing by hand things the language supports directly now. So for example, and the standard library. So for example, you know, the old joke about, yeah, I can't define it, but I know what it is when I see it. Well, I know what the old non-modern code is when I see explicit delete a lot. I know it's old code if I see a for loop iterating over every element of every iterator, every index in a range instead of range 4. I know it's old code when it doesn't use auto even to avoid saying vector of foobar of map of blah iterator. Const, I think.
Which one is const? I can never remember which one is const. Is it the key that's... Ah.
Oh, now you're thinking about sets and maps.
Yeah. So I have been through a couple of updates to quote modern C++. The most recent one was actually what, 2 years ago when LLVM flipped the switch. Yes, I'm looking at you. I believe it was 2 years ago when the LLVM project just decided that no, we were going to require a C++11 compiler to build LLVM. 18 months ago? Something like that. Something like that. Anyway, and it was interesting because we just flipped the switch and made sure everything worked, and then it was fine. And then we just started getting this flood of patches. Let's rip out this homegrown unique pointer that the LLVM codebase had in it. Both of them. Both of them. And replace it with std unique pointer. And let's do this, and let's replace this with a range-based for loop, and this with a range-based, and use this, and use standard function, and dun 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 dun. And we had the advantage of having a large group of contributors who were rather enthusiastic about ripping out old code. But I mean, it was a lot of things happened in that code base, and the code base got smaller and got more reliable. I didn't run any benchmarks, so you'd have to ask other people.
I would like to generalize that. Once you modernize your code, you have a better base for further improvements because it's easier to understand, and you have trained your people to actually see the improvements. Yes, it'll get smaller. That means negative productivity, but don't measure by code size. And it usually improves performance.
My experience is also it's likely to get more correct. I've spent a lot of time correcting reference count implementations other than shared putter, and most of them have a much lower probability of being correct than the shared putter implementation.
I'd say another hallmark of modern C++ is use of RII every time it makes sense. Anytime you see code that's managing any kind of resource manually, it's doing manual cleanup work, that is very much a sign of old code, of code that could benefit from modernization, and as Hans says, would be safer and more correct probably if that were done, and faster.
Hans just reminded me back when in the mid-2000s when we were still on the way of getting the smart pointers into the standard library and homegrown implementations. I remember working for and doing some consulting work for a company that had, as everybody did, their homegrown counted pointer implementation that was just like shared pointer but with camel case and with a really buggy weak pointer. And so I implemented it for them. And boy, did I get more respect for how hard it is to get weak pointer right. I mean, shared pointer is, like you say, enough. But weak pointer? There are subtle bugs there. Just Google boost.org for Peter Dimov's comments because I had to look at his weak pointer implementation, and his comment pointed out a bug I hadn't thought of, where you basically can't do a cast on a dangling pointer. And that's important. Because it might, if there's virtual inheritance, it might try to look at the V table. Yeah, there be dragons. So I'm really glad it's in the standard, and I never have to write that again.
I do.
All right, go ahead and say your name and.
Hi, my name is Eric. This morning in Bjarne's keynote, he showed
frustration in some of the progress of the committee and entertained the universe where he was dictator instead. And that was God, dictator, it was one of those. Which got me thinking, in that alternate universe in which any of you had been a dictator, what decision would you have made wrong? What has the community saved you from had you been dictator?
Ooh, that's a courageous answer.
Everything.
Well, I just admitted that I started loving C++11 allocators last month. And
There are, of course...
Ignore him, we do.
There are, of course, languages that has benign dictators for life. And I think any authoritarian system like that will work very nicely for a short period of time. Then power corrupts.
Well, it's not just about power. It's about, we all make mistakes. And if we stop listening, we stop learning, and we're going to make more of them. For instance, let's take an example from a completely different community. I know people who've been active in JavaScript standardization for some time. And Brendan Ike, brilliant guy, had a very, in the middle of some JavaScript version, had a very, the details don't matter, very strong opinion that we needed to do X. This was really important. People needed it. And different members of the committee came to them with data from users showing actually people don't need that. They don't do that. They really need this thing, though, which this would kind of prevent. He listened. That's a good example. And if it weren't for the group of people around him, he would have made a terrible mistake, done something not useful that would have closed the door. Now, yes, you have the other problem when you have too many cooks as well. So there's a balance there. But anybody is going to make mistakes. And so no matter what our job is, never be a dictator, even if you can be in your corner of the world and don't have to listen to people. Still have a habit of listening because it will save you and you'll be glad you did.
Okay, over here.
So
Oh,
I was going to
sorry.
add one thing.
Yeah.
Can I say try? No. That I was wrong. No, the point is, I think I want to say is none of us know the whole language completely. I think it's an amazing thing that we actually really do rely on each other to find out about things, parts of the corners that we don't know. I mean, that's just the fact of it.
All right, I think we're over there.
Hi, my name is Tarek. I was just wondering, as a committee, have you guys thought about standardizing some sort of tooling support, whether that's formatting, refactoring, or whatever? As much as I love executing Clang format, I want to say compiler executable dash format my file. Or is that a bad idea?
I think to a certain extent that's a little bit out of the scope of what we'd be comfortable standardizing. It's clearly something that the community has been in need of for quite some time, and the tools are now starting to become generally available and of a very high quality. But I think if we were to standardize it, if we were to standardize any form of tooling beyond, say, reflection support, then we would, if anything, be limiting people's ability to innovate new tools and saying, you go in this direction, rather than improving things.
So as a follow-up to that, how about exposing some common API that people can use to build their own tools, but that's common to every single platform and every single compiler?
So, two things. First, I want to actually answer your first question. I think we could standardize formatting of source code about 2 days after we standardize on the VI editor and switch everyone from Emacs and with tabs. With tabs. Okay. but like about 2 days after that, we'll be able to standardize how you format source code.
And you put spaces on both sides of the star, right?
I'm not even going to dignify. So that's one of the challenges you're facing here, right? Is that the language isn't actually amenable to certain kinds of standardization because there's not this huge value proposition for doing it, and there might be small ramifications to trying to push people in that direction. But the other thing is that we don't need to. That's one of the beauties of a standard language, right? As long as the language is standard, we can have different tools all interoperate. They actually have a common API right now, and that's actually the language. And that's the key idea of the language standard. And so to a certain extent, we have exactly as much standardization for tooling as we need. All the tools know what the spec is, they can implement it, and they can build the tooling on top of it. And we've seen over the last 5 years a tremendous renaissance of tooling for C++, and so I don't think that we're missing anything to make those tools available. Now, I want to address the API thing, though, because that gets to reflection. And I think that there might be a good use case for standardizing a reflection API within your program. And in fact, I'm chairing a study group that's pursuing that. But that's a very limited task. A lot of tooling extends far past what reflection can do. And so for those tools, I think that the interface you want, the interface you really need there is just the language itself. And we're already in really good shape there.
I actually think we can do slightly better for tooling. People have been trying with ASTs, abstract syntax trees. I don't think they work. There's nothing, we need more than syntax, and they have to be DAGs. But we could have a non-textual representation of the language to make tooling easier to create.
Just to follow up on Chandler's comment about the source code being really the portability API for tooling, I think that's very valuable and true. And the place where it does fall down a bit and which is getting better is vendor extensions. And I work for Microsoft. So, and one of the nice things is that all vendors, including Microsoft, are de-emphasizing extensions. Sometimes the extensions are there because you just couldn't say it in standard C++ before. There are several talks at this conference where, I think one was today, where they're talking about how, well, now we can, so we don't need this extension anymore. And the more that we can do that, and the other compilers are getting their permissive minus switches, this further helps tools to work on anything without having to say, oh, if-def that compiler, and be able to detect these extensions that break their logic because they're not C++ source code, really.
Okay, I think we're over here.
So I'm Gaspar. I was watching your talk, Bjarne, today, and I saw all those lists that you put up of features that you wished had made it but didn't quite. And there was one glaring omission, to me at least, on which you wrote a paper on, which is open multi-memory. And as a follow-up second part of the question, are we still so hung up on complicating the linker?
That list was what I thought to be within the scope of 18 months, 2 years. And I did not think that there was any chance, hell, of open multi-methods making it in that. And it's not on my path of things that are absolutely necessary. I would love it, but it's not on my top 10. Furthermore, I should emphasize that I did not think that we could take all of the things on my list and finish them in 18 months. Even though, as people have pointed out, most of those are shipping today. They're just not in the standard. We have to balance things. There are different interests, there are limited resources, and I've been working on the multi-methods at some point. I've been working on other ways to eliminate the visitor pattern, which I think is a horrible workaround, to run faster than that. And there's other things I've been working on, like some form of functional programming like pattern matching to get rid of problems with unions and such. And they weren't on that list because they were not within a 2-year horizon. And we have to regularly reevaluate where we would like to go.
Okay. Over here.
One more question. I'm interested to know the cross-fertilization between C++ and many other languages. So since C++ is such a successful story and there's lots of lessons for other language to learn from, and can the panel give some examples where other language actually picked up some really good, cool features from C++, and also C++ learned from other languages, particularly during those plateau years in that growth chart that Bronnie this morning talks about.
So do you guys ignore all the other languages?
There are other languages?
So something that that Bjarne touched on in his keynote was we do actually try to not be too inventive. Like if there are lessons that we can learn from other languages, we do try to do so. And we do definitely look at things which work well in other languages, like lambdas, like range-based for, and incorporate those.
Between the various members of the committee, we actually do know all the other languages. It's just no individual does.
Yeah, for concurrency issues, certainly we look at other languages fairly regularly, and I try to make sure that we don't overlook things. In many cases, the features of other languages are not directly portable, of course, and there are major issues that need to be overcome in order to do the analogous thing in C++.
But the, as Marshall just said, the ideas behind them are extremely valuable. Right now, for instance, I'm looking at heterogeneous computing. I'm looking at 3 or 4 other languages that have already pioneered some of these things, but specifically with the view of seeing how they do it well for C++. And that's been extremely instructive. Now, we're not going to copy them exactly. What will end up most likely is some sort of integration of that, but doing it from C++ itself, from the ground up.
Thank you.
Thank you.
Okay. Hi, I'm Pepe. I'm going to ask you the other mandatory question, which is, can I ask each and every one of you which language feature or library feature would you like to see in C++ tomorrow morning implemented and working across all the compilers? And then I want to see the 8 of you mic on stage.
Doesn't Clang already have them all?
I don't know, Richard, are you done? well, then why are you up here?
He's not just the project editor, he also edits Clang.
I don't really know what single feature I would want more. We have a lot of stuff in the pipeline that I think is great. For my day-to-day programming, though, structured bindings and the little things like the if condition change are so good that I'm still kind of all starry-eyed. It'll take me a few years before I can really be grumpy about the lack of a particular feature. I'm still excited about the candy that I've got coming down the pipeline.
I'm similar. I'm like, I think many of you, at least when people approach me and talk about C++, I actually rarely hear, oh, when are you finally going to do this feature? Like everybody has a pet feature. I far more often hear, boy, we're having trouble absorbing all this good stuff. And I can't use the latest compiler yet because, it's the absorbing. How do I learn all this? So, there is a fire hose that we're pointing at the world of good features, and I'm absorbing them too. So what you said is pretty much my experience also. Like, did I mention allocators?
I think you did.
You're not going to try?
As with Chandra, I've had a lot of fun with structured bindings and with if and switch init statements. I guess I'm a little bit privileged in that I'm fairly frequently the first person to have a working compiler having these features which I can write test cases for. That's pretty fun. So in some sense, I already do get to play with these new features every day.
One observation is that very often the major demand for a feature doesn't actually arrive till the feature is there in the compilers. That is, it's hard to think about a feature you can't use, and people at large do not think about it very much. By the way, there's 3 features I want in my compiler tomorrow morning. It is, of course, concepts, modules, and structured bindings, and I have them. Unfortunately, not in the same compiler.
We can give you 2.
But a serious answer, though, I'm thinking about it and looking at Casey, I do look forward to the day I can write portable code with ranges, because I do get tired of writing .begin, .end. I'm lazy, sorry.
Or is it because the M key has now totally disappeared from your keyboard? So just to close up, I never really think about any one feature. C++ really needs multiple features to really work well sometimes, and I really like the fact that when they come together, it's almost magical.
If I had to pick one feature, it would probably be concepts, because that would make it easier for me to implement ranges for Herb. I get to implement almost everything range related twice, right? I do it once in the style of the ranges TS using concepts for my implementation that runs on GCC, and then I do it again for range v3 because we try to mirror our implementations of everything. And that means I know exactly how much easier it is to implement these things with concepts than it is to do it without, or with the emulation of concepts in range v3.
I'm kind of in the same boat as Richard is, except from the library side, is I get to play with all the new stuff as soon as I write it, or as soon as Eric writes it. So that's a lot of fun, and I'm looking forward. Well, these are not features I wish would be in tomorrow, but because they are going to be in tomorrow. But the new vocabulary types in C++17, any and variant, and optional, but optional's been here for at least a little while. They're going to change a lot of ways people think about structuring their data structures and structuring their code, and it'll be interesting to see. For a while, they've been, earlier versions have been in Boost for a long time, and they've been very popular.
On the concurrency side, there are actually a few things that I would like to see. So I would like to see executors in, mostly so I don't have to apologize. I can stop apologizing for async and its shortcomings. And I would like to see some concurrent data structures, which turn out to be hard as well, but that's also something we're working on.
Okay, I think we're over here now.
Yeah. Hello, my name is Miodrag, and my question is mainly for Mr. Herb Sutter. Question is regarding the study group for 2D graphics. Since it changed the name, what are the new goals, and for what do you need help of community?
So the question about the graphics study group, which has changed names a couple of times, mostly just to avoid making people think that we're doing GUI widgets, because we're not. Right. So the actual mission has not changed, and it's basically Michael McLaughlin and some friends are helping drive a tour to TS, a library that initially wrapped Cairo, so it's that level of API, but in a C++ way, to do 2D graphics rendering. Mainly the short spiel is, I should be at least able to do basic output. I do console output in C++. What does that mean on a phone? Some things don't have a console, like graphics or putting something on the screen to interact with in a simple way is something that ought to come in the box. And there are some proposals that are coming also for input as well. But that's pretty much where that's staying for now. We'll be happy if we can complete that, because that's a big chunk of work. And I think it's really the most, at least for now, that should be standardizable. If some 3D graphics folks want to come along after that and invest their personal time and energy and expertise, be happy to see that. But let's get the basics.
So I know there's more questions, but I'm going to kind of interrupt. You guys have been helping us a lot, obviously working on the standards, you're helping us a lot tonight. What if somebody out here is excited about helping you? How do they get involved in helping you? What do I do?
Patches, welcome.
Okay.
Seriously, I'm the maintainer for libc++, a standard library implementation. You go to libc++.lvm.org. That's where we have a bunch of documentation on our pages. You can find my name there. That's Marshall. We also have at bugs.lvm.org.bugs. We have bug lists, things that need to be fixed. You can find a list of all the features for C++17s and which ones are done and which ones aren't. If you want to get involved, I will happily take a look at your stuff and give you advice and say, oh yeah, you can't quite do it this way, we need to do it like this, and I welcome more help.
If you want to help one of us, we've each got email addresses, and if you can't find it, you're not trying hard enough. For the guidelines, which is not for extending the language, but for helping people to get on board with more modern C++, go to the GitHub, look at it, make contributions, we take them in, right in the GitHub.
So I understand the difficulties of trying to get involved. I know that people think that there's this hurdle. You may have to be represented by some company. You have to get through some national bodies. The honest truth of it is that you don't have to do any of that. Any of these study groups, any of us are completely open to outside injection of opinions, papers. We know there is this STUD proposal group. It's not totally monitored, so if you put a proposal there, no, it's not necessarily the case that we're going to all find it and move it forward. But in every case, people. So one of the things that I find interesting is that coming to meetings, yes, do require some financial support and things like that. And it is true that in order to get ideas through, you do have to be persistent. You do have to keep coming, or have someone keep coming for you. But there's nothing wrong. But these days of the internet, there's nothing wrong with joining study groups online, which are all pretty much open. You don't even have to represent any particular company or even represent that you have expertise. In all the times that I've been on these study groups, chairing them and running them, I've only had to kick one person. No, I didn't kick one person out. He actually voluntarily left because he had to go back to school, which is very nice of him. So we welcome a lot of people. We welcome a lot of, that's a really easy way in. I actually think.
14.
14.
No, SG14.
Yes. SG14 is one of the biggest, one of the groups that has been very successful because it's a known industry name group. You may not know what ranges mean or what concepts mean, although if you don't, you probably shouldn't be here. But still, SG14 is about low latency, about games, about now it's also about financial trading, about simulations, real time, and embedded programming. So that pretty much covers a good part of the universe.
And if they wanted to participate in that, where could they go?
Thank you. So it's just Google ISO CPP SG14. You'll find the study group instantly.
We're going to pull teeth here. Herb, you hold it down. I'll pull the teeth out.
This week here. What do they do like tomorrow?
Oh, tomorrow.
Tomorrow or the next day.
Or the next day. All right. Now I got it. I just flew in last night. Thank you. Yes, so tomorrow morning, I think we're going to have like a half-hour session about what we're going to do in SG14. And then Wednesday, you're going to be able to attend an actual standard meeting. Okay, well, we're actually going to go through papers. I didn't think people liked that, but you guys are crazy. You guys actually want to listen to us reviewing interfaces and papers and things like that. So welcome. Tomorrow morning, I will be handing out, or the people who are going to be there are going to be handing out stickers. They have the word ISO on it, and you can just put it on, and that's your entrance ticket. Thank you. I really just flew in last night.
Okay, I think we're over here now. Okay.
Hello, my name is Tobias, and when you're talking to embedded programmers, you often hear that C++ is not well suited for embedded. You should use C instead.
Why?
Yeah, that's like where we're going to. And when you dig a little bit deeper, then you talk to them and they program C++ like you learn it in the textbook. And that's obviously wrong for embedded because that has different constraints. So how can we get away from that? How can we make C++ successful on embedded?
Should we tell them to watch Dan Sachs' talk tomorrow at 11 o'clock?
And SG14 has now absorbed the entire embedded. So there used to be this embedded, pseudo-embedded working group. And SG14 has absorbed the entire group. And we are doing things. One of the big push, so this year, the big push I tried to push through was financial. Following up on that, we're going to be, and I've already have a great deal of connection. So just to review, SG14 is going to be making a big push about embedded. But these things are already happening in the standard. There already have been features. We talked about things like, I think there was an attribute about on main that if it doesn't return or no return. There's discussions about exceptions, how to handle those things. So there are actually proposals that are going on right now and been in discussion for some time, and we're going to carry on those proposals. And so I welcome you guys who are thinking about how to do that in a constrained environment. So we are listening.
There is a lot of myth about what can and cannot be done with C++ and should be and should not be done. This is possibly especially true in the embedded world, even though it's not restricted to that. I would say that is an area where we need to write better code and understand the better code and what is better. We need guidelines because lots of it is there already and people don't know it or they don't believe it and they believe the myth. And some of the C myths are so deeply ingrained that people don't feel they have to argue for them. I mean, C is better and faster and easier than C++, right? No question, no discussion, and it's wrong. And so maybe if somebody would look to the guidelines too, that would be a side way for bringing people up to date. I mean, flat data structures, flat containers are really good, and you can have them today. It's not rocket science.
So
though it is used in rocket science too.
I promised you that I'd be rude to you, and I'm going to be rude to Michael right now. Because the question was, C programmers don't think that C++ should be used for embedded, and your answer was, we're fixing that. No, it's not broken. Bjarne's right, it's an attitude thing, it's myth. And I think that's the answer. So I'm being rude to you, Michael.
So, and let me just follow up very, very briefly in 2 or 3 bullets. What are the key constraints of embedded systems that matter to them, where they think C++ is not suitable? Can you just quickly name 2 or 3?
Memory.
Memory? Like what's small?
Depends on who you're talking to.
Pick a number.
A few hundred kilobytes.
Okay.
CPU.
CPU, what's small?
I don't know.
Template load, okay, but so object code size, binary size, okay. In addition to Dan Sachs's keynote tomorrow at 10:30, come on Thursday at 10:30 for Jason Turner's plenary session. Wednesday. Are you sure?
Yeah, pretty sure.
Excellent, that's even better.
Yes.
Come to Jason Turner's, where he will use modern C++ 17 and targeting devices considerably smaller than that.
I'm going to interject here. I think it's important to understand the viewpoint of the different groups. So I understand where you're coming from, and I do hear an earful of it as chair of SG14. So my actual answer was that we already have these things, actually. Yeah. Not that we're fixing it, but I do understand where they're coming from, because
the whole point SG14 started was to cover exactly the question that Herb was asking about. The fact that, you know, about how much memory things takes up. We are really good, but we could do better. And I think I think we can all agree on that.
Yes.
From a different point of view, they might see it differently, but yeah.
I heard the
Take
word
it back, Michael.
template bloat, which usually is for people who don't know how to use templates and don't know their toolchain. I was once working with some people who were doing flight controls, and the discussion was whether templates should be banned or templates should be allowed with special permissions. When we were finished, they were compulsory. And the reason for that was it eliminated certain areas, and in particular it eliminated unused code, which is banned by the rules for flight software. And so if instead of using a struct, you use a templated struct, even if you only instantiate it once, you know that the unused functions are not used. If, on the other hand, people do what was very popular in the 90s, they take a classical object-oriented hierarchy with dozens of classes and many dozens of virtual functions and slap a template on it, boy, do you get bloat. So don't. That's what guidelines are for, among other things.
I have an anecdote. Anecdotes are not data, I know, but I was recently talking to a large hardware company, who shall remain nameless, who is settled on C++ to write hard drive controllers software in. These are pretty much by definition very small devices. They're the kind of things that they're going to spend a few cents on hardware. And so it's not going to have much memory, it's not going to have much CPU, but C++ is their language of choice for that.
So I'm sorry to talk more about this because I want to make sure we actually talk to more questions. But there's one issue that I have with all these. I agree with a lot of what's being said here, but I don't think any of this answers the question. Because the question was not, are these people right? The question was, what can we do about it? Okay? And so the interesting thing is that regardless of how accurate I believe all of these statements are, there remains a large body of people who believe very firmly that they can't or don't know how to use C++ in an embedded context. And while I'm hopeful that SG14 will eventually give me more ideas about what these people can do about it, I would like to give a response of what you can do about it today. And so what can you do about this today if you find yourself in this discussion? Number one thing, point out that C++ is a menu of features, all right? You don't have to get everything. And so ask people, like, what is it you don't want to use? Okay, fine, don't use that. I mean, I think you should use templates, don't get me wrong, but get them using C++ first, right? And then introduce a feature and show them how it makes it better. And then introduce another feature and show them how it makes it better, right? Take an incremental strategy here. All right, so I've gone through a lot of C++ adoption problems before, right? So my company was very afraid of adopting C++ 11. And what we did was we actually implemented a crazy thing, a terrible thing, right? We turned off every single C++ 11 feature. I'm not kidding. We actually changed the compiler to turn off every single C++ 11 feature. And then we turned on C++ 11. Now that may seem like a really silly thing to do to a lot of people. All right? No one understood what we were doing. We kind of waved our hands and like, no, it makes our implementation better. That wasn't the point. All right? The real point here was that once we had done this, we could conduct an experiment with one C++ 11 feature. And we could show people, hey, look, it works. Like, the world doesn't end, the sky does not fall, the castle does not crumble into little rocks. And in fact, it's all okay. And you can show them the trade-offs that they get to have. Code gets smaller, right? You get to deploy nice generic code that solves real problems. We also found a bunch of bugs in our C++ 11 implementation, and we got to fix those before they were widely deployed. So maybe you'll even find problems with C++ that you'll have to fix to make the embedded environment work. But the key is to make it incremental, right? Actually demonstrate the problems here. And it's one of the most amazing things about C++. If I can't use exceptions, fine, I'm not going to use exceptions. I mean, it limits me, don't get me wrong, but the language is still there, and there are still facilities available. And so that's what I would tell you to do to actually, make progress where you are.
That's very constructive. You're triggering in with me also that if you don't happen to own a compiler, sorry, we're just not. We're not all lucky. That even if you don't own a compiler, C++, all that C code they're writing, nearly all of it compiles to C++. Now you can start doing a very similar thing. When you talk to a C programmer, there are certain things that you can get where you can almost certainly show a benefit. Q-sort's one. Use std sort. If you switch them from Q-sort to std sort, and their code is easier to read and faster, then the people who really believe that they're using C because they really believe it's faster, they'll start to go, ooh, candy. And you'll start to be able to appeal to them and suck them in and see, hey, look, I can see a benefit. But the key is that you can change just a few lines of code without disturbing your whole application and see a benefit. That's the key to any incremental adoption. So if you can find a few things like that, pieces of code they find hard to maintain, or that they rely on being fast and therefore they write it in C. Maybe something small that you can try to rewrite in C++ and show them a benefit, especially in performance or space, the cost in time or space, and that will be pretty persuasive to somebody who is driven by data and by facts and will listen to a real benefit.
There's a number of debunking papers out there. Does anybody have a collection of those?
I really want to, I know that you want to move on, but I really want to close by saying SG14 is the place. We are collecting all the embedded people, all of you guys who are embedded programmers, and I bet there's a lot more than out there that's listening to this. We are going to make a big push, so please join SG14. Some of this might be myths, some of these are real, maybe real. We believe these cases. We really just need to sort it out.
Okay, so we don't have very many minutes left, so we're going to go into 2 and 2 mode. 2 responses, 2 sentences. Do you got a better idea? One response for each question and a limited response. 5 words? We may run out of questions at that rate. Okay, give us your question.
Herb had a recent paper where there was specification of sequence points to make sure that code that was in Bjarne's book actually compiles and does things correctly. So for the first time, at least to my knowledge, there are things that are being specified now in C++ that were left unspecified or implementation defined in C. Is this something that we can look forward to more? Because every single time I talk to an embedded programmer and they give me a horrible example where C++ fails, it's always from its base C language. Right? So is it fixable? Are you guys going to fix that?
I can't answer in 5 words, but I will. But I'll try a sentence or two. So we're fixing some things. The order evaluation, for example, is still conforming to C, because if C leaves it unspecified and you specify it to be something, that's compatible in the right direction. So we are doing some improvements in a compatible way. That's all I have time for.
All right. What's that? Okay. Over here.
So, field programmable gate arrays and C++ compiler. Bad idea? A very bad idea? Or if it's not a bad idea, if there is anything competitive with Verilog as opposed to OpenCL?
Awesome idea. Use LVM first.
Over here.
Okay, so the C++ compilers need to handle a lot of code because of the current compilation model, because of textual includes, and once modules are introduced, the compilation speed will get much better. So I was wondering whether when we get this performance budget, are we willing to spend it on, for example, more sophisticated type deduction, or more or better, more convenient grammar, or do we want to just enjoy the compilation performance and keep the things as it is?
Compile time acts as a gas. It expands to fill all available developer patience.
One benchmark, 600 milliseconds.
That may not be a complete answer, though. It may be 5 words.
Look up 6. Look it up.
Okay. Okay, over here.
Hi, my name's Tim. And first, I have a shameless plug for my talk, because as Bjarne said, knowing your tool chain for controlling template bloat is something that I can demonstrate. Is sort of, ruining the surprise. LLVM's not that bad, because it's not worse than Intel, but it's not that good.
Oh.
Okay, so.
You only get 5 words.
Oh, that's not even my question. Sorry.
Patches, welcome.
Yar, them there be fighting words.
Okay. So, although discussed subsequently, I was a little surprised to hear that no one talked about the if switch declaration being their favorite new thing in C++17. It was discussed subsequently, but not initially, because everyone was very glad to see structured binding, although the two work extremely well together. So, anyway, but my question is, I, being in scientific computing, am very glad to see some of the mathematical stuff coming into C++17. And I'm curious if the numerics working group has interest in bringing in things like integration routines, optimization routines, root finding, and things like that, so I can stop using GSL, because it's written in C.
Not yet. Papers welcome.
Papers welcome. Okay. Sorry, I have one more question. I have to.
One word.
Okay. So this is for the entire committee, but what is your favorite statistical computing package language name?
I think you got that one in 0 words.
I will open the question to the audience.
Wait, statistical? You said statistical computing package?
Yes.
Today is September 19th.
Thank you.
Arr!
All right, over here.
I have a very specific question. If you capture by value in a lambda, it doesn't remove CV. But if you use foo equals foo, it does. Why?
And you have 5 words.
Because some people worried.
Init capture uses auto deduction.
All right, I have an equally specific question for Bjarne, because you mentioned this was your favorite feature, or possibly Richard, because you probably edited the wording. The new constructor deduction of constructor parameters, how does that work in the presence of partial specializations of the class template?
5 words.
In 5 words or less. It doesn't is acceptable.
Constructors from the primary template.
Okay.
Okay, this requires just like a 1-word answer. Suppose I got an idea and I meet you here at the conference, say, hey, that's a good idea, you should submit a paper for some working group. Is there some kind of mentoring process that could help me writing my first paper, my first proposal, saying, yeah, that's a good extension to the language, to the library?
I don't know if there's a mentoring proposal. I would not suggest that you become a TS author and not ask anyone how that's supposed to work.
So what do I do?
ISOCPP.org.
That's it.
Submit a proposal.
Okay.
Okay, so this is another 1-word answer possibly. concepts and ranges being put in the international standard together or separately? So ranges are dependent on concepts, so.
I don't think we can put ranges in the working paper without concepts. If for no other reason than because it would require so much of ranges to be redone without
But would that
concepts.
require concepts to be delayed until ranges are ready is more what I'm asking? So because ranges is like the library for concepts?
Both together soon.
Is SDL2 allowed to fix stud max?
Yes, but will it?
All right, so
There's nothing wrong with it.
it's broken. No, it's broken. So talk to us a little bit about the foundation and ISO cpp.org. What we find there if we wanted to get involved in the process. What's on that website to help us learn about the standards process? And you can use more than 5 words. And then when you're finished, Richard's going to sit down and
ISOCpp.org,
play us off.
standardization, and forums.
Okay? All right? Richard, the piano is right over there. There's no question.